Hello. In our previous lesson, we have looked at how we can find the domain and the range of a function. And we mentioned that for the domain of a function, they refers to all the elements within a function whose image can be found, right? So the images that are found will represent the range. My name is Nana Wedu, and you can call me Senana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all the videos that I put out here on time. In this lesson, we want to consider how we can find the domain of a function. So we are going to use some examples of various functions to be able to determine how we can find the domain of a function. So basically, let's look at this question. The question says that find the domain of each of the following functions. So you have been given various functions. One of the functions is f of x equal to 2x plus 1. Another function is g of x is equal to square root of 16 minus x. We have another function which is 4 all over 3x minus 2. And then we have another function h of x which is equal to 3x squared plus 5x minus 4, right? So let's look at how we can find the domain of these functions. So first and foremost, let's write out the domain of each of the functions, right? So the first function that has been given to us is 1, f of x is equal to 2x plus 1. So we see that this function is a linear function. Specifically, it is a polynomial function. And we see that for polynomial functions, all values of x that we put here within the real number systems will give us f of x, which is in the real number system. So no exception. So we can see that the domain here in Joseph's form will be equal to x such that x belongs to the member of all real number system, right? So that is the domain of a polynomial function, any polynomial function. Now with the second question, we have been provided with a radical function, and the function is g of x, right? And it is equal to the square root of 16 minus x, right? So what we need to see is that we can use inspection. So by inspection, we can see that basically when we have these terms, right, the numbers here, when you have x to be 16, we can have the square root of 16 minus 16, which is the square root of 0. And we know that this gives us 0, right? We can also have 15, right? We have square root of, let's say, 16 minus probably 15, which will be the square root of 1. And that will also give us, right, 1, which is a defined term. Now, let's use a higher value more than 16. So if you have square root of, right, the x value being 17, we have 16 minus 17, and we know that gives us square root of negative 1, right? So by inspection, we can conclude that the domain of the function, right, the domain of this function in Joseph's form will be x such that, right? So let me clean. S such that S is a member of all real number system where x is basically less than or equal to 16, because from 16 and below, that is when the functions are probably defined. In other ways, we can take the value in the square root, which is 16 minus x, and then we equate it to, or we let it be greater than or equal to 0, right? This implies that we are going to move our x across the equal sign to this side, right? So we are going to have 16, right, is greater than or equal to x, or x is less than or equal to 16. So any which way is the same thing, right? So x is less than or equal to 16, or 16 is greater than or equal to x. So therefore, we can write the domain as what? S is said that S is a member of all real number system where x is less than or equal to what? 16. So that is the domain for the radical function. You take the numbers in the square root and then you let it be greater than or equal to 0. Then we find the value of x, the inequality. And you realize that the values of the domain will be less than or equal to, right? In this case, what we got, right? So let's look at the third one. So in the third question, we've been given a polynomial function where we have f of x, right? So f of x, and that is equal to 4 all over 3x minus 2, right? So we know that for the domain of a rational function, we want to ensure that the denominator does not become 0. because when the denominator becomes 0, the function becomes undefined. So we take 3x minus 2 and we equate it to 0. So we have 3x is equal to 2. We divide both sides by the coefficient of the x, which is 3, and that gives us our s to be equal to 2 over 3. So we can write the domain in true set form as x such that x is a member of all real numbers where x is not equal to 2 on 3. So 2 on 3 does not satisfy the domain of the function, right? And then the fourth question, we have a quadratic function that have been given. So the quadratic function given is h of x, right, which is equal to 3x squared plus 5x minus 4. And we know that quadratic functions basically belong to the polynomial functions. So the domain of polynomial functions, all the x values in the real number system will satisfy. So we'll say that is x such that x is a member of the real number system. So we have gone through a series of questions where we have looked at different types of functions and we've been able to determine how we can find the domain for the different types of functions. Remember to like this video, share this video, and subscribe to my YouTube channel. In our next lesson, we will look at another example on finding the domain of a function. See you in the next lesson.